Welcome to Spring LIB.
In this exercise, we have a train that slows down as it makes a curve. So the train starts with an initial speed VI equals 90 kilometers per hour, and the final speed is 50 kilometers per hour. The curve has a radius 150 meters, and the time it takes for the train to complete the curve is 15 seconds. And we have to calculate what is the acceleration of the train when it has a speed of 50 kilometers per hour. So the first thing I'm going to do is to transform the speeds from kilometers per hour to meters per second. And all we need to do is to remember that 1 kilometer per hour is equal to 1 over 3.6 meters per second. So what we need to do is to divide the speeds by 3.6. So 90 divided by 3.6 is 25 meters per second, and 50 divided by 3.6 is 13.89 meters per second. Now suppose that here at the first spot that I'm marking with the number 1, the train has the speed of 90 kilometers per hour, and here it has a speed of 50 kilometers per hour. Remember that the acceleration has two components, one tangential component that is tangential to the trajectory. I'm going to call it AT, and it's pointing backwards in the opposite direction of the motion, opposite to the direction of the motion, because the train is slowing down. And it also has a radial acceleration AR, since the train is changing direction as it moves. And we can calculate both of them. So the tangential acceleration is just the variation in speed divided by the variation in time. Okay, supposing that it is constant. So this is the final speed, 13.89, minus 25, this is in meters per second, divided by the time, which is 15 seconds. So the acceleration, the tangential acceleration, is minus 0.74 meters per second squared. On the other hand, the radial acceleration is v squared over r, and when the train has a speed of 50 kilometers per hour, that is 13.89 meters per second, we have that this is 13.89 squared meters squared per second squared divided by r, which is 150 meters. So the radial acceleration is 1.29 meters per second squared. And then, since both of them are perpendicular to one another, the acceleration is just the square root of the radial acceleration squared plus the tangential acceleration squared. So this is the square root of 1.29 squared plus 0.74 squared. So this is 1.48 meters per second squared. That's the magnitude of the acceleration. So in order to completely determine the vector, we also need to determine its direction. So here, suppose that this is the acceleration vector. I'm going to calculate the angle it makes with the radial acceleration. So notice that in this case, the tangent of theta is the tangential acceleration divided by the radial acceleration. So the tangent of theta is AT divided by AR. So this is 0.74 divided by 1.29. So this is 0.574. So theta is the arctangent of 0.574, which is 29.8 degrees. Okay, so 1.48 meters per second squared, that's the acceleration, and 29.8 degrees is the angle.